If you've watched the other two videos before this, you know that we're just writing models that would represent the area of these different figures we're looking at. This case is no different. This time I have a rectangle in the center, and then I've got two semicircles around the outside. Well, two semicircles put together are going to make a circle, and so my thinking this time is I'm going to find two separate areas. I'm going to find the area of the rectangle, which is just length times width, and I'm going to find the area of just one circle, because two semicircles make just one circle, and that's pi r squared, and then add those two areas together to get a function that would represent the area of this entire figure. So let's go ahead and see what we've got this time. They tell me the width of this is just going to be represented as x. I don't know the width of this rectangle. They tell me the length is going to be 20 less than 3 times the width. And so to represent this, I have to be careful with that 20 less than. Remember, what it means is I have to take 20 away from 3 times the width. So when you hear it that way, hopefully you recognize that the width, or the length I guess, is going to be represented as 3x minus 20. That 20 less than has to come at the end. So let's start with the rectangle. This is very much like we did in the last video. To find the area of a rectangle, it's length times width, so x times 3x minus 20. And all I can really do with that is distribute, so I'll go ahead and do that and get 3x squared minus 20x. Okay, let's go ahead and switch and figure out what the area of the circle will be. And remember, we don't care about two semicircles, just make it one big circle. The area of a circle is, of course, pi times the radius squared. Well, I'll need to figure out what the radius of this circle is, and at first glance it looks like it might be difficult. However, remember, I already have the diameter of the semicircle, the diameter of the circle. They told me it was x. The width of the rectangle is the same as the diameter of that semicircle, even though this is not quite drawn to scale. So since I know the diameter is x, if I go ahead and draw the radius in, since I know the radius is just half of that, I can express the radius of this circle as x divided by 2, just half of the diameter. And so using that, let's go ahead and write an expression that would represent the area of the circle. So it's pi times the radius squared. We just determined that the radius is x over 2. Okay. If you watched our first video in this series, we talked about how to multiply or square these fractions. Just square the top and square the bottom, so x times x is x squared. And I'm going to throw the pi up there too, so pi x squared. Over the bottom would get squared as well. 2 times 2 is 4. So the area of the circle, the one circle, the two semicircles, is pi times x squared over 4. So to finish this problem and write my expression for the total area of this figure, I'm just going to add these two individual areas together. And to write them as a function of x, once again I'll do this. The a of x is equal to, and there's no like terms in anything, so I'm just going to list these pieces all added together separately. So 3x squared minus 20x. I want to add on to that the pi x squared over 4. And so here's the function that I'm looking for that will model the area of this figure.